This is Algebra 1, Lesson 14, Evaluation of Algebraic Expressions. All of these examples, 7, 14 divided by 2, 4 plus 3, negative 21 divided by negative 3, and 2 plus 2 plus 2 plus 1, are all expressions. They are numerical expressions because they're made up of just numbers and operation symbols. They all have a value of 7 because if you simplify each of these, they're equal to 7. So those are the first two terms in this lesson, numerical expressions and value. It's just basically what it is worth or what it would be if you simplified it. Now let's look at this expression. This expression has a variable in it. What do I mean by a variable? Well, that is a letter that stands in the place of some numerical value. So we would call this an algebraic expression. Some would call it a mathematical expression. We're going to look at that compared to numerical expressions just a minute, but you can see that this does have a variable in it, and its value will depend on the value of x. So if I said x is 1, then the value of this expression would be 4 plus 1, which is 5. Or if I said x is 0, the value of the expression would be 4 plus 0, which is 4. So that's the value is going to depend on the value of x. It's going to depend on what x stands for. And we talked about variables. Variables can also be called unknowns because we don't know the value. Sometimes we have to find out what it is. So the book will use those interchangeably. And then there's also a constant in this algebraic expression, and that would be the 4. Okay, the 4 is a constant because 4 equals 4 equals 4. But the x is a variable because we can say x is a different value each time. Okay, but 4 is called a constant. Now, I think this is best explained and summarized by a Venn diagram. So I've included a Venn diagram here for you to see. I'm going to zoom in a little bit here just on the graphic part of it. Your book would call this part here numerals, okay, instead of numbers, but that's okay. Individual values with no operation symbols. We know what those are. 1, 2, 3, 4, 5, 6, 7, 1/2, 2.3. Those are your numbers. Then you have numerical expressions that are expressions that can contain only numbers and operation symbols, like we were just looking at, numerical expressions. And then you have the algebraic expressions, expressions that contain one or more variables. They may also contain numbers and operation symbols. And there's some examples over here to the side. Okay, algebraic expressions, they are going to have your variable in there. Not all of them, because as you can see, algebraic expressions includes numbers and includes numerical expressions. Okay, so this is like when we looked before at systems of numbers and we said all natural numbers are whole numbers, but not all whole numbers are natural numbers, right? That same kind of nested Venn diagram. Numerical expressions, it gives you some examples here, and then numbers as well. And then it gives a great little reminder at the bottom, all numbers are numerical expressions, right? Because numbers are inside the set of numerical expressions. All numerical expressions are algebraic expressions because it's inside, but not all algebraic expressions are numerical expressions, just like we've talked about before. So pretty good summary here if you want to take a little screenshot and include it in your notes. That may be helpful, and we'll refer back to it. How do you indicate addition, subtraction, and division in algebraic expressions? Well, you can see here we've got a plus indicating addition. This also indicates adding the opposite or adding a negative. So subtraction is considered addition, algebraic addition. You can see a division here in this fraction, just the same as here, right? We've got some different operation symbols down there. So you use the same symbols, but there's one little bit of a change. How do you indicate multiplication in algebraic expressions? And I've listed the book examples here. These are the ones that we're familiar with, okay? We've been seeing things that look like this. We've seen things that look like this, and this, and this. Those are pretty common to you. But now we're going to begin looking at things like this. What does that 4x mean? Well, it means 4 times x. So if I tell you x is equal to 2, then 4x is not equal to 42. Okay? That's a common mistake. 4x is equal to 4 times 2. And we'll often put the value of x in parentheses, which would be equal to 8. So I'm pointing this out to let you know that in algebraic expressions, when you have a number next to a variable, it indicates multiplication. And you've probably all seen that, but I'm going to point it out like the book does. So here's another not official example, but just something they were pointing out. They were showing that if you had an expression like this, x, y, m, that has a value if given some values for the variables. So if we know that the x is 1, and we know that the y is 2, because they gave us that, and the m is 3, then this is not 123. This is 1 times 2, which is 2, times 3, which is 6. This expression has that value of 6 when x is 1, y is 2, and m is 3. Let's look at another one. 4x plus mx. If you put in that x is 3, you would have 4 times 3, not 43, plus m is 5 times 3, which is the value of x. So we just inserted each value. Now we use our order of operations. We know we have to do multiplication before we can add. We can go ahead and do this multiplication. Now we're going to add those, and we get 27. Okay, so when they give you an expression, they're going to give you values for the variables, and you have to find the value of the expression.